Hi, my name's Kate Robertson. I'm from the Geological Survey of South Australia. We've done a feasibility study for marine MT in the shallow coastal waters of the Spencer Gulf in South Australia. And I'd like to acknowledge all of my co-authors in this work. It was a very collaborative project that we embarked on. So it was led by Professor Graham Heinzen at the University of Adelaide, and with funding from AuScope, from Geoscience Australia and Geological Survey of South Australia, and from the Scripps Institution of Oceanography, who shipped the instruments over from San Diego. So a lot of project guidance came from Scripps as well, and the preparation and maintenance of the instruments. So marine MT is not too dissimilar from land MT, except for the fact that we're putting the instruments out at the bottom of the ocean. A lot of, I guess, differences in the way that the actual instruments themselves are designed, but I'll go into that in the next slide. But I just wanted to show you a couple of sort of cool examples that have been done using marine MT. So on the left is some work from Samer et al. In 2013 that was published, where we have imaging of a subducting plate. In the middle, we've got imaging of a more resistive groundwater amongst saline surrounds. And then on the right, we have the imaging of resistive salt domes in the otherwise conductive surrounding sediments. So there's a lot of practical considerations to be made when acquiring marine MT data. I mean, there is inland as well, but the considerations are very much different to what you would have to prepare for. So in land MT, you're avoiding things like fences and houses and roads. With marine MT, things like tides and currents play a big part. So we acquired the data in the end of late November 2020, and if you have a look at the chart on the right, this is showing the tides, and you can see where you've got high tides, where you've got these sort of large waves, and then the small tides, so this sort of band that comes through. And so with the box there, I've highlighted where we had some of the smallest tides. This is what's known as a Dodge tide in the Spencer Gulf. You have considerations with water depth as well, both the logistics of kind of getting a ship into the water. We have fishing concerns with prawn fishing, and also with shallow water, you've got a lot of water movement as well. And so the movement of water can cause the magnetic coils, which need to be really stable, to sort of jiggle around a little bit. And then the movement of water as well creates electric currents, which causes noise in the electric fields as well. So it's all about trying to minimize the risks of these things causing an issue to the data. You need a lot of time and space to sort of prepare your gear beforehand, before you head out on the ship. So our team went up, I think, 3 or 4 days early, and managed to use the fishing company's shed to sort of get everything ready to go. We were unfortunate that there was a COVID lockdown. So this actually unfortunately meant that due to the sort of tight scheduling of the fishing vessel, we, instead of deploying the instruments for 4 to 5 nights, we ended up deploying them for 2 nights, which wasn't as long as we wanted. So, as I mentioned before, the instrumentation has a bit of differences. Again, we're still recording the magnetic and electric fields. We're not creating that signal. It's the natural signal that's already occurring. And this is just sort of a sketch of what the instrument looks like. I highly recommend, if you would like more detail on this, to check out the paper by Steve Constable et al., published in 1998. It goes into a huge amount of detail and basically tells you everything you'd ever need to know about marine MT. So there's a lot of these instruments that are hosted at Scripps in San Diego. They've got about 150 of them. They were built in-house in the early 2000s. And the group at Scripps is led by Professor Steve Constable, who helped us a lot with this project along the way. And this is just a quick time lapse of deploying a site. So we put in the electrode arms, we put the coils in, we get the compass going, and the GPS recording, taping up lots of holes that we don't want sediments to get into at the bottom, which can make the instrument really heavy. And then, so quick, you probably missed it, but we use a crane to chuck it over the side. And You can see here, so we just sort of hold on to it, keep it nice and steady, lower it into the water, and then it's a quick release with the crane. And Lauren waving goodbye to the instrument. And you can see we had some lovely water to sail on. It was beautiful, lovely sunsets. Seems like all fun and games, and then sort of as we got to nighttime, it got quite rough where we were. Perhaps to people who regularly go out on ships, this might not be too rough, but to probably us who spend more time doing land MT, yeah, we found it quite bumpy. But overall, it was a really enjoyable experience, and you didn't have to dig any holes, which was, I think, by far the highlight of marine MT compared to land MT. So we did the work in the Spencer Gulf. For those who aren't familiar with where that is, so this is South Australia and into New South Wales, Victoria. So we've got sort of Adelaide around here. So we've got the York Peninsula, Adelaide around here. We've got the York Peninsula here, the Eyre Peninsula here, and this gulf in the middle is the Spencer Gulf. And if we look at the model in the background, so this is the AuSlamp model. So this is from the land MT sites. They're every 55 kilometres, the site spacing. And here we're looking at a 20-kilometre depth slice. So in the Gulf, you can see we've got sort of a bit of high conductivity here and down here. And you can see that it's sort of an area where there's a lot of interest in what's happening to the features that we see on land when they enter into the oceans. So this, I'm just going to quickly show you a model of the data. This green line is the transect. So we had Land MT, the Tumby Bay survey, which is a paper just published, and then the new marine data, so roughly along this green profile. So this is what the model looked like when we just had the AuSlamp data. So you've got Eyre Peninsula with the air conductivity anomaly, then you've got the Spencer Gulf, and then into the York Peninsula. So this was, to remind you, it was long period MT data, 55-kilometre spacing. Then we add in the new broadband MT data. So broadband is more targeted for crustal, whereas long period is targeted for sort of mid-crustal to it's kind of the full lithospheric mantle. So you see the air conductivity anomaly come out in quite a lot more detail now. Got some really resistive rocks from the Donington granitoid package. And we've got the kind of southwestern extent of the Eastern Nacre Arc anomaly there coming under the Hiltiver Suite, which is a intrusive package associated with a lot of the IOCG mineralization further north. So this is using a modeling code Mari 2DEM, which is a completely open source code from Kerry Key, who is at Lamont Doherty Earth Observatory, was at Scripps when he developed the code originally, but keeps developing it. Yeah, it's great for marine and land MT data. So that's a great resource to have there too. So what are the opportunities going forward? So we've kind of had the opportunity to re-establish marine MT as a technique in Australia. The last marine MT survey was in about 2003, one that Graham Heinsohn was involved in. And so, you know, it's been a long time. So that's what, 18 years since there's been a marine MT survey. So, you know, we've got this great collaboration with, you know, these national bodies, but also with Scripps, who have the instruments, they have the facilities, and they have the expertise. They're also willing to, you know, very keen to work with us further in the future to help sort of broaden the scope of I guess our capacity to acquire marine MT in kind of large scale. So what could we actually do going forward? So on the left, I've just pinched a slide from a talk from Alison Kirkby. And this is a depth slice of 36 kilometres. So this has a variety of different AuSlamp models sort of around this area and up in the north, overlaying from what was previously our sort of best image of the conductivity of Australia, which was only made from 57 sites using GDS sites instead of MT, which means we're not actually recording the electric fields. So it's very hard to constrain absolute resistivities and the depth of features. So I guess we really want to take note of the features that you can see in sort of this area and here where we've got these newer models. And there's some models missing, so Tom lost us in Tasmania, for example. But you can see kind of near the coast, we've got a lot of really interesting conductivity features. We zoomed in on this one. So we've got opportunity. We could acquire more marine MT data in this Spencer Gulf as a kind of a grid to really help constrain the extent of these features. We've got the Bass Strait in the Gulf of Carpentaria. We've got these interesting conductivity anomalies. There's a lot of potential opportunities there. And this was a figure made early on in AuSLAMP from Geoscience Australia, which was just showing, what could AuSLAMP look like if it was extended to the continental shelf. And so these are kind of all the areas where we really have this potential to acquire these data sets. And of course, it is not actually constrained to the continental shelf. We can certainly extend, if we had a question of interest, off of these shelf regions too. So how would we make this feasible? So, I mean, what we'd done for this previous survey is we'd shipped over, Scripps had shipped over for us 12 marine MT instruments, and we'd done that using the small fishing vessel, which worked perfectly for those purposes. But if we really wanted to sort of make a dent and really kind of understand the extent of, for example, the metal fertility corridors that we're seeing, the deep signatures of mineral systems with AuSLAMP, see what happens to them offshore, for example, then we're going to need a bigger sort of scale project. So an option would be to have Scripps send over a bunch of their instruments, possibly personnel, and we could really get a large project happening for perhaps several years. But yeah, so I think there's a lot of room for collaboration for potential projects in the future. Obviously, huge coastal region around Australia, so lots of different questions we can answer, and groups that are willing to collaborate and work on this going forward. So thanks very much.